Hello students, welcome to our continuing series Basics Explained, in which we cover the basics of topics that you are likely to see on the SAT and the ACT. Today we look at the basics of linear coordinate geometry, an important topic for both SAT and ACT math. So linear coordinate geometry revolves around the slope of a line. If we have a line that connects 2 points x1, y1 and x2, y2, then the slope of the line is defined as rise over run, where rise is the distance between the y coordinates and run is the distance between the x coordinates. So the slope of the line, which is generally given by m, is given as y2 minus y1 divided by x2 minus x1, where x1, y1 and x2, y2 are any 2 points on a line. So the question is, why is the slope important? Let's look at why this is an important feature of any linear equation. Basically, the slope gives us the inclination of a line with respect to the x-axis. Let's say that the line makes an angle alpha with the x-axis, and let's say that this point is x1, y1, and this point is x2, y2. Then I know that this distance is y2 minus y1, and this distance is x2 minus x1. So by the property of trigonometry, I can see that y2 minus y1 divided by x2 minus x1 will be the tangent of angle alpha, tan alpha. And since y2 minus y1 divided by x2 minus x1 is the slope, we can say that the slope is the tangent of the angle that the line makes with the positive x-axis. Now, this gives us some important conclusions. When you have an angle between 0 and 90 degrees, which is known as a rising line, something like this, then the slope will be positive because the tangent of any angle between 0 and 90 is positive. When the line is a falling line, which means something like this, it would make an angle with the positive x-axis, which is between 90 and 180. And since the tangent of such an angle is negative, the slope of a falling line is negative. So this is an important rule which can help us work with options when we have a number of options in the questions, right? So for example, the rising line on the left has a positive slope and the falling line on the right has a negative slope. Okay, from the corollary of the slope being the tangent of the angle that the line makes with the positive x-axis, we can say that a horizontal line will have a slope of 0 because the angle that it makes with the x-axis is 0, while the slope of a vertical line will not be defined because the angle that a vertical line makes with the x-axis is 90 degrees and tan 90 degrees is not defined. So a vertical line slope is not defined, right? So basically, we can see that if I have a line and I start rotating that line, right? So I start with the horizontal line denoted by purple, and then I rotate it. So my slope will gradually increase since tan alpha will increase till it becomes undefined when the line is vertical, denoted by the purple vertical line. And then if I rotate it further in the anti-clockwise direction, my slope will become negative. And now from negative infinity, it will increase and it will come back to 0 when the line comes to the horizontal position, right? So it's like it starts from 0, increases positively, goes up to infinity when it's vertical. And the moment it gets into the second quadrant, it comes from minus infinity and the slope increases gradually, negative, increasing, and then finally comes back to 0. So if you understand that, it is useful in any question related to slope. Now, when we talk about parallel lines will have the same slope because the angle that they make with the x-axis is the same. So let's say that this angle is alpha and this is also alpha. So obviously, if this is m1 and this is m2, then m1 will be equal to m2. So parallel lines have the same slope. With perpendicular lines, the product of the slopes is -1, which is to say that the slopes are negative reciprocals of one another. So let's say that this angle is alpha, and let's say this is beta. Then this angle inside would be 180 minus beta. And since this is 90, we can say that alpha plus 180 minus beta is also 90. So alpha is beta minus 90, right? I can say that alpha is beta minus 90. So tan alpha will be tan beta minus 90, which is minus tan 90 minus beta, which is minus cot beta. So tan alpha is just negative cot beta. So m1 times m2 will be tan alpha times tan beta, which is minus cot beta times tan beta, which is -1, right? So that's a quick derivation of how the product of the slopes of perpendicular lines is -1. You don't really have to remember this derivation. As long as you remember the concept, it's enough. Okay. Let's now look at some of the equations of a line on the coordinate plane and how the slope plays a role. The most common equation is known as the slope-intercept form, given by y is equal to mx plus c, where m is the slope and c is the y-intercept. So this distance is c and m is the slope of the line, right? So this is the most common equation because it represents y as a function of x. Another popular equation is the slope point form, where we are given the slope of the line and a point x1, y1 on the line. In that case, the equation becomes y minus y1 is m times x minus x1, right? Which is to say that y1 and x1 are the coordinates of the point and m is the slope. In general, the standard form of the line is given by ax plus by is equal to c. And when it is given in this standard form, the slope is minus a by b. This can be verified. If you look at ax plus by is c, I can say by is minus ax plus c. So y is minus a by bx plus c by b. And if we compare this to the slope-intercept form, the slope is indeed minus a by b, right? And a line that passes through the origin has the equation y is equal to mx, because here it has no y-intercept. So the plus c part disappears because c is 0, right? So these are some of the important equation formulas for the equation of a line on the coordinate plane. Let's do a few sample questions that will further explore this topic. Sample question 1, a line with a slope of 5 passes through the points k7 and -1, -3. What is the value of k? So we know the slope is y2 minus y1 divided by x2 minus x1. Slope is given as 5. Let's say this is x1, y1, and this is x2, y2. So -3 minus 7 divided by -1 minus k, which is -10 by -1 minus k. When we cross multiply, -10 is -5 minus 5k. So 5k is 5, so k is 1. The value of k is 1. Okay, let's look at another question. In the xy plane above, line M is perpendicular to line L, not shown. Right? So line L is not shown, but we know that it's perpendicular to this. Which of the following could be an equation of line L? So we first find the slope of this line. So we pick up 2 points. This is 0, 3, and this is 1, 2, 3, minus 5, 0. So the slope of line M would be 3 by 5, right? So the slope of line L will be negative 5 by 3, the negative reciprocal of the slope of M, since M and L are perpendicular. So what is the slopes of each of these lines? They are given in the standard form, ax plus by plus c is 0. So the slope will be minus a by b. So for option A, it's minus 5 by 3. For B, it is 5 by 3. For C, it is 3 by 5. And for D, it is minus 3 by 5. My desired slope is minus 5 by 3. So my answer is option A. Right, so that was a quick preview of the slope and the linear equation on the coordinate plane. If you found this useful, please hit like and subscribe to the channel. Let me know in the comments section what other videos you'd like me to upload in general or as part of the Basics Explained series. I'll see you guys in a new video soon. Take care. Bye-bye.